All right, so this presentation is on gas law stoichiometry. This is a concept that we covered when we began doing mole conversions, and we have done some gas law stoichiometry. But all of the gas law stoichiometry we've done was at STP. Okay, so STP is standard temperature and pressure. Standard temperature is 0 degrees Celsius, or if we're plugging it into any gas law equation, we would need to plug that in as Kelvin, 273 Kelvin. And standard pressure is 1 atmosphere. So if we wanted that to be in millimeters of mercury, it'd be 760. In torr, it'd be 760. If we were doing kilopascals, it'd be 101.325. But we're just going to keep it in atmospheres for right now. So you were told back when we did mole conversions with volume that the volume of 1 mole of gas at STP is 22.4 liters. So you could use the value 22.4 liters equals 1 mole only if the equation was at STP, at standard temperature and pressure. So now that you've actually worked with the ideal gas law, PV equals nRT, we can verify that 1 mole of gas at STP is 22.4 liters. So let's go ahead and plug that in just to verify that I was telling you the truth. So our pressure for standard pressure is 1 atmosphere. Volume, we know that it's 22.4 liters, but we're actually going to verify that right now. And we're talking about 1 mole of gas. R is still going to be 0.0821 liter atmosphere per mole Kelvin. And temperature is standard temperature, which is going to be 273 Kelvin. Okay, so again, we are trying to figure out what the volume of gas will be at standard temperature and pressure. So 1 atmosphere, 273 Kelvin, and we said that was 1 mole of gas. So we're going to go ahead and plug that in to the equation, and we are solving for volume. Okay, so if you combine these terms, you're going to get X equals 22.41 some other numbers liters, okay, which we just round to 22.4 liters. Okay, so if we have 1 mole of gas at standard temperature and standard pressure, it will in fact have a volume of 22.4 liters. Okay, so I worded this first question a little funny, and then I'll show you in terms that you're more used to looking at. But what volume of hydrogen would be needed to produce the volume of 1 mole of ammonia at STP? The volume of 1 mole of ammonia at STP, we just verified. 1 mole of a gas at STP is 22.4 liters. Okay, so here we go. Same question. What mass of hydrogen would be needed to produce 22.4 liters of ammonia at STP? Okay. So we are looking for mass of hydrogen, and we are given liters of ammonia. So we're going to solve this just like before. You would want to refer to your stoichiometry graphic organizer if you're unsure what steps to take. Okay, so we are starting with liters of ammonia. So the first step is to go from liters of ammonia to moles of ammonia. Okay, and we're going to do that using the molar volume of gas. Okay, and molar volume of gas is 1 mole equals 22.4 liters. Sorry, I wrote that kind of funny. Okay, liters cancels out. 22.4 divided by 22.4 is 1 mole. So we're starting with exactly 1 mole. Then we need to go from moles of ammonia to moles of hydrogen. So if you still have not bothered to learn stoichiometry, you can go back and refer to my other videos that go through this a little slower. But this is just a review. We've done this before, been tested on it. Okay, so in this step, this is ratio of coefficients. So we're going to look at the coefficients from the balanced equation. So we have 3 moles of hydrogen reacting to form 2 moles of ammonia. Okay, these are going to cancel out. 1 times 3 divided by 2 is 1.5 moles of hydrogen. Okay, and now that we have moles of hydrogen, we can go to liters of hydrogen. Mass of hydrogen. So we'll match the units to go from moles to grams or mass. We're going to use the molar mass of hydrogen. So the mass of hydrogen is 1, but the formula is H2, so it would be 2 grams. So 1.5 times 2 would be 3 grams of hydrogen. Okay, if you prefer to do all the steps in a line, I'll show that to you really quickly. Okay, so we would know that this is going to be 3 steps. We're going to need to go from liters of ammonia to moles of ammonia. And then we go from moles of ammonia to moles of hydrogen. And the last step, we're going moles of hydrogen to grams of hydrogen. Okay, so I'll go ahead and fill in those numbers. So molar volume of gas is always 22.4 liters equals 1 mole. Ratio of coefficients, we're going to the balanced equation. Okay, molar mass, periodic table, and you will still get 3 grams of hydrogen. Okay, so all of the problems that we've done so far with this, as far as stoichiometry is concerned, occurred at STP. So the question is, what happens if it's not at STP? So in this situation, you are given the pressure and the volume and the temperature that it occurs at. Okay, so in the previous equation, you already knew that 22.4 liters equals 1 mole at standard temperature and pressure. So what do you do if you have conditions that are not standard temperature and pressure? So got 2 players here. So we'll set this up just like we did when we did solution stoichiometry. Okay, so what mass of nitrogen? And then it's giving you a bunch of information for hydrogen. So it's saying 3 liters of hydrogen at 1.2 atmospheres and a temperature of 298 Kelvin. Okay, so you are given a bunch of variables that could be plugged into the ideal gas law equation. So what we're going to need about hydrogen is the number of moles that is going to react, so we can then figure out the mass of nitrogen. Okay, so your first step, we have enough information to plug it into the ideal gas law equation. Okay, so this is your volume, your pressure, your temperature. Okay, R is always going to be 0.0821 when we're using these units. Okay, so there's my pressure. The volume is 3 liters. We are trying to figure out how many moles so that we can do stoichiometry to get to mass of nitrogen. R is 0.0821, and the temperature is 298 Kelvin. Let's leave the units out because that sometimes throws students off. Okay, so I'm going to go ahead and solve this. And I got 0.147 moles. Okay, and remember this information was given about hydrogen. So this would be moles of hydrogen because we used our volume of hydrogen, our pressure for hydrogen, our temperature for hydrogen, and so on. So we have moles of hydrogen. Okay, so now that we have moles of hydrogen, we can go ahead and use that to solve for mass of nitrogen. So in order to get to mass of nitrogen, first I've got to go moles of hydrogen to moles of nitrogen. So ratio of coefficients. So this is just like the solution stoichiometry. Right, and I'm going to go to the balanced equation, of course, to get my coefficients. So 3 for hydrogen, 1 for nitrogen. And I got 0.049 moles of nitrogen. Okay, now that I have moles of nitrogen, I can find the mass of nitrogen. So molar mass is always 1 mole. And I would go to the periodic table to find the mass. It's 28 grams nitrogen. And I got, let's call it 1.37 grams of nitrogen. Okay, so again, we were given enough information here to solve for moles of gas. So in the solution stoichiometry, we were given enough, sometimes we were given enough information to solve for moles of, from the molarity equation, and then we use that to do the stoichiometry. So now we're just using ideal gas law. All right, let's do another problem. Okay, how many moles of ammonia would be produced from 2 liters of nitrogen at 3 atmospheres of pressure at a temperature of 25 Celsius? So let's go ahead and separate our information. So we're dealing with ammonia, and it's asking for moles of ammonia. And we are given some information about nitrogen. Okay, so anytime you have 2 different compounds in your word problem, we know that we're going to be doing some kind of stoichiometry. You're going to need to use ratio of coefficients. Okay, so we're given some information about nitrogen. We're given the pressure. We're given the volume. We're given the temperature, which is 25 Celsius, which would be 298 Kelvin. Okay, and then R is always the same for ideal gas law. So we have enough information here about nitrogen to find moles. Okay, once we have moles of nitrogen, we can go ahead and solve for moles of ammonia. So let's plug this into the ideal gas law equation. Okay, we're solving for moles again. Okay, and then you're just going to solve for X, so whatever way you feel comfortable doing that. And I got 0.245 moles. Okay, remember all this information was about nitrogen, so that would be moles of nitrogen. Let's switch colors here. So now that I have moles of nitrogen, I can go ahead and solve for moles of ammonia. So that's just going to be one step, so we just go moles to moles. Okay, ratio of coefficients. All right, coefficient for nitrogen is 1. Coefficient for ammonia is 2. That would be 0.49 moles of ammonia. And that is it.